Tsar Bomba is the nickname for the AN-602 hydrogen bomb, the most powerful nuclear weapon ever detonated. Its test on October 30, 1961, remains the most powerful man-made explosion in human history. It was also referred to as Kuzakina Mat, referring to Nikita Khrushchev's promise to show the United States a Kuzakina Mat at the 1960 United Nations General Assembly. Developed by the Soviet Union, the bomb had a yield of 50 megaton TNT. Only one bomb of this type was ever officially built, and it was detonated in the Novaya Zemlya archipelago, at Sukhoi. The remaining bomb casings are located at the Russian Atomic Weapon Museum, Sarov, and the Museum of Nuclear Weapons. All-Russian Research Institute of Technical Physics, Snezhinsk. Neither of these casings has the same antenna configuration as the device that was tested. Background. Many names are attributed to the Tsar Bomba in the literature. Project 7000, Product Code 202, Article Designations RDs 220, RDs 202, RN 202, AN 602, Codename Vanya, Nicknames Big Ivan, Kuzakina Mat. The term Tsar Bomba was coined in an analogy with other massive Russian objects, the Tsar Kolokol, Tsar Tank and the Tsar Pushka. The CIA designated the test as Joe 111. The Tsar Bomba was a three-stage bomb with Trutnev-Babiev second and third stage design, with a yield of 50 to 58 megatons of TNT. This is equivalent to about 1,350–1,570 times the combined energy of the bombs that destroyed Hiroshima and Nagasaki. 10 times the combined energy of all the conventional explosives used in World War II. 1/4 of the estimated yield of the 1883 eruption of Krakatoa, and 10% of the combined yield of all nuclear tests to date. A three-stage H-bomb uses a fission bomb primary to compress a thermonuclear secondary, as in most H-bombs, and then uses energy from the resulting explosion to compress a much larger additional thermonuclear stage. There is evidence that the Tsar Bomba had several third stages rather than a single very large one. The initial three-stage design was capable of yielding approximately 100 Mt. But it would have caused too much nuclear fallout, and the plane delivering the bomb would not have enough time to escape the explosion. To limit fallout, the third stage and possibly the second stage had a lead tamper instead of a uranium-238 fusion tamper. This eliminated fast fission by the fusion stage neutrons, so that approximately 97% of the total energy resulted from fusion alone. There was a strong incentive for this modification, since most of the fallout from a test of the bomb would have ended up on populated Soviet territory. The components were designed by a team of physicists headed by academician Yuliy Borisovich Kharitonin, including Andrei Sakharov, Viktor Adamski, Yuri Babayev, Yuri Smirnov, and Yuri Trutnev. Shortly after the Tsar Bomba was detonated, Sakharov began speaking out against nuclear weapons, which culminated in him becoming a dissident. Test. The Tsar Bomba was flown to its test site by a specially modified Tu-95V release plane, flown by Major Andrei Dernovzyev, taking off from an airfield in the Kola Peninsula. The release plane was accompanied by a Tu-16 observer plane that took air samples and filmed the test. Both aircraft were painted with a special reflective white paint to limit heat damage. The bomb, weighing 27 metric tons, was so large, long by 2 meters in diameter, that the Tu-95V had to have its bomb bay doors and fuselage fuel tanks removed. The bomb was attached to an 800-kilogram parachute, which gave the release and observer planes time to fly about 45 kilometers away from ground zero. When detonation occurred, the Tu-95V fell 1 kilometer from its previous altitude because of the shock wave of the bomb. The Tsar Bomba detonated at 11:32 on October 30, 1961, over the Mityushka Bay nuclear testing range. north of the Arctic Circle over the Novaya Zemlya archipelago in the Arctic Sea. The bomb was dropped from an altitude of 10.5 kilometers. It was designed to detonate at a height of 4 kilometers over the land surface over sea level by barometric sensors. The original November 1961 AEC estimate of the yield was 55 to 60 mount, but since 1992 all Russian sources have stated its yield as 50 mount. Khrushchev warned in a filmed speech to the Supreme Soviet of the existence of a 100-mount bomb. Although simplistic fireball calculations predicted the fireball would hit the ground, the bomb's own shock wave reflected back and prevented this. The fireball reached nearly as high as the altitude of the release plane and was visible at almost 1,000 kilometers away from where it ascended. The mushroom cloud was about 64 kilometers high, which meant that the cloud was above the stratosphere and well inside the mesosphere when it peaked. The cap of the mushroom cloud had a peak width of 95 kilometers and its base was 40 kilometers wide. All buildings in the village of Seveny, located 55 kilometers from ground zero within the Sukhoi-No's test range, were destroyed. In districts hundreds of kilometers from ground zero, wooden houses were destroyed, stone ones lost their roofs, windows and doors, and radio communications were interrupted for almost 1 hour. One participant in the test saw a bright flash through dark goggles and felt the effects of a thermal pulse even at a distance of 270 kilometers. The heat from the explosion could have caused third-degree burns 100 kilometers away from ground zero. A shock wave was observed in the air at Dixon Settlement 700 kilometers away. Window panes were partially broken to distances of 900 kilometers. Atmospheric focusing caused blast damage at even greater distances, breaking windows in Norway and Finland. The seismic shock created by the detonation was measurable even on its third passage around the Earth. Its seismic body wave magnitude was about 5 to 5.25. Analysis. The Tsar Bomba is the single most physically powerful device ever used by mankind. For comparison, the largest weapon ever produced by the United States, the now decommissioned B-41, had a predicted maximum yield of 25 megatons of TNT. The largest nuclear device ever tested by the United States yielded 15 megatons of TNT because of an unexpectedly high involvement of lithium-7 in the fusion reaction. The preliminary prediction for the yield was from 4 to 6 megatons of TNT. The largest weapons deployed by the Soviet Union were also around 25 megatons of TNT, as in the SS-18 Mod. 3 Icbm Warheads. Much of its high-yield destructiveness was inefficiently radiated upwards into space. It has been estimated that detonating the original 100-mount design would have released fallout amounting to about 25% of all fallout emitted since the invention of nuclear weapons. It was decided that a full 100-mount detonation would create too great a risk of nuclear fallout, as well as a near certainty that the release plane would be destroyed before it could escape the blast radius. The Tsar Bomba was the culmination of a series of high-yield thermonuclear weapons designed by the Soviet Union and the United States during the 1950s. Films. Footage from a Soviet documentary about the bomb is featured in Trinity and Beyond, the atomic bomb movie, where it is referred to as the Russian monster bomb. The movie states that the Tsar Bomba project broke the voluntary moratorium on nuclear tests. In fact, Soviets restarted their tests and broke the unilateral voluntary moratorium 2 months before Tsar Bomba. And since the moratorium was unilateral, there was no multilateral legal obstacle. A 1-hour episode of the PBS documentary series Secrets of the Dead, World's Biggest Bomb, chronicles the events leading to the detonations of Castle Bravo and the Tsar Bomba.